So I have a sequence here, and my question is this sequence monotonic or not? Well, the first thing I'm going to do to answer that question is I'm going to actually calculate some of these numbers. You can get an extra calculator and do it. You can do it in Excel. It's pretty easy to do there. Um, when you do that, you're looking for one of two things. First, you're looking to see if you can spot places where the sequence changes direction. Where first it's going up, then it's going down, then it's maybe going up again. All it has to do is change direction one time, and that's enough for it not to be monotonic. This sequence didn't do that. Right? This sequence, the numbers appear to be strictly increasing. It's constantly going up. So based on that, that's what I'm going to try and show. I'm going to try to show that this sequence is not just monotonic, but specifically that it's an increasing sequence. Okay, so how am I going to do that? Well, to do that, what I'd like to try to do is come up with a formula for the nth term of this thing. And to get there, I'm going to look at some of the individual sequence terms, right? So the first term, a sub 1, is the square root of 2, which is 2 to the 1/2. It's going to be easier to see what's going on if we do this with fractional exponents instead of that square root thing. Now, to get to the second term, I take the first term, multiply it by 2, and take the square root of that value. So if I do that, I get this expression here. I'm going to substitute 2 to the 1/2 in there for a sub 1. Then I'll just do a little algebra, manipulate the exponents. That comes out to 2 to the 3/4. Okay, so let's do it again. Right? If I go for a sub 3, that's square root of 2 times a sub 2. Same substitution. Work out the exponents. That's 2 to the 7/8. Okay, good. I'm starting to see a pattern here, but let's do one more. A sub 4 is the square root of 2 times 2 to the 7/8. Same manipulations with the exponents. We get this is 2 to the 15/16. And now I'm really seeing the pattern. The denominator is 2 to a power, and that power is the sequence number. And the numerator of the exponent is 1 less than the denominator. Okay, so that means that my nth term is 2 to the n minus 1 over 2 to the n. And it's not quite what I want. I'm going to simplify this just a little more by taking the fraction that's in there in the exponent, splitting it into two fractions. 2 to the n over 2 to the n minus 1 over 2 to the n. And if we simplify that, we get this thing. This is the formula that I need. Now, from here, you could just kind of look at this and say, look, 2 to the n, that's an exponential function. Exponential function is strictly increasing, which means 1 over 2 to the n is strictly decreasing, which means minus 1 over 2 to the n is strictly increasing. You kind of talk your way through this being a strictly increasing function. Normally, I kind of discourage that sort of thing, especially with kind of younger students. There's an awful lot of pitfalls to doing that. It's easy to accidentally make an assumption that you shouldn't have made. Okay, so while I do think you could get away with doing that here, what I'm going to do on the next one, I'm going to approach this more analytically. I'm going to actually show mathematically that this function is strictly increasing and therefore monotonic. Okay, so over here, I've got two things. First, I've just got the formula, just so we've got that in front of us. And second, I have what I want to show. Right? Again, based on my numeric calculations, I see that the numbers appear to be increasing. And to show that the sequence is increasing, I need to show that the m plus first term is always going to be strictly bigger than the term that came before it, than the nth term. All right, so here's how I'm going to approach that. Right, so I'm sorry, just to be clear, what I'm looking to have happen, I want that inequality there to be the very last line of my argument. Right, if that's the last line of my argument, then that's what I've shown, and we've made our conclusion. So here's what I'm going to start. I'm going to start just like n is less than n plus 1. And clearly that's true, right? N is a positive integer. So that's always going to be the case. Well, if this is true, then if I raise 2 to both of those powers, the inequality is still true. Then if I flip both of those over, if I make it 1 over 2 to the n and 1 over 2 to the n plus 1, the inequality changes direction. Okay, so a couple things. First, hopefully you see where I'm going with this. I'm kind of trying to build up that 2 to the 1 minus 1 over 2 to the n, right? That's kind of what I'm working towards. All right. And second, I want to be real clear about this step. The only reason I could do that is because 2 to the n and 2 to the n plus 1 are always positive. If it was any way possible that sometimes one could be positive, sometimes one could be negative, this wouldn't work, and you couldn't just do that flip it over thing I just did. Okay, so from here I'm going to multiply both sides by -1. Of course, that switches the inequality again. Then I'm going to add 1 to both sides. You notice I've got the exponent now, right? So if I raise 2 to those powers, just like I did back on the second step, I get this. And that's what I really wanted to see, right? The left-hand side is just a to the n, and the right-hand side is a to the n plus 1, which means a to the n plus 1 is greater than a to the n, which is exactly what I needed to show. I shouldn't have said it that way. A to the n is less than a to the n plus 1. I don't know why I got it in my head to say it backwards, but either way, that's what we need to show that this sequence is monotonic. Okay, so if you'd like to get the full context, you can click on the upper link here to see the lecture on monotonic sequences that kind of preceded this example. And the other link will take you to the next lecture in the series, which is where we're going to talk about bounded versus unbounded sequences. And of course, if you like this presentation, please don't forget to click on the like button down below as well.